Yes, sir, we can start now. As all of you know, our course title is AI and ML. Okay. So, especially nowadays, mostly we are talking about AI applications. Full form of it, artificial intelligence. Actually, in a high level, artificial intelligence is just a theory. But what are the expectations we are going to achieve by the artificial intelligence? We need some sub-disciplines. That means here, AI is a set of some sort of sub-disciplines such as machine learning, deep learning. Of course, before the deep learning, there is a concept called neural networks. With the base of the neural network, deep learning is derived. Okay. And then NLP, such kind of things. And also very recently, one more discipline came to the picture, that is generative AI. And one more thing came to the picture recently, that is the responsible AI, which is responsive or responsible AI. In this way, many disciplines, sub-disciplines within this AI. So by taking combination of all these different disciplines, we are forming one intelligent applications. So just like how human is behaving, how human is thinking, how human is taking the decisions, and human is predicting the things. Similar to that, your application could able to do all the things. Okay. I think recording is going on. Annapurna, once session is completed, the recorded sessions will be shared to all of you. So don't worry.
Okay.
So even you don't worry about the notes also. Okay. So whatever the session that we are taking, so this entire text document will be shared with you. Okay.
Okay. Thank you.
So come to this one, forget about prerequisites and the climax of this session. What are all the prerequisites? From where to we need to start all these things we will be discussing. So try to understand what exactly the machine learning, and then what is deep learning, when to use machine learning and deep learning. This kind of understanding we do, at least for today. I'm going to talk about this machine learning. Simply the short name ML, let's call it as ML. Before going for this, ML versus statistics, we need to understand. Suppose in statistics, we are doing the predictions. In machine learning also, we are doing with the help of machine learning also, we train the models and finally we do the predictions. Okay. So then what is the statistical style and machine learning style? First, we need to understand. So in case of statistics, on given data, we apply some formula. To construct a relationship, that means to understand the relationship between, to find the relationship between input variables and output variables. So this kind of technique, this kind of models are good for the simple patterns of the data. Suppose if our data has a complex patterns, at that time the statistical predictions are giving sometimes wrong predictions. Suppose less accuracy will be getting. Suppose I got an accuracy 70% of accuracy by one statistical model, means out of 100, 70 predictions are good, 30 predictions are getting failed. But in case of ML, we are trying to achieve more good accuracy. Even though complex patterns available in the data, okay, we train the models in such a way that the prediction accuracy will be very good. That means the prediction quality will be very good. So here, to understand about this machine learning, first of all, what is machine learning? Any idea, all of you? If you have any idea, can you please type? Can you text, please? Any idea? Sound is not coming up. Okay, already some answers delivered. Train the missions, train the missions. Yes. In fact, we don't train the missions. Okay. Yes, Satya, machine learning is a subset of AI. Very good. Okay, but what that subset is doing? Like, what exactly the machine learning? Srinivas, last few years prediction is said. Okay, source code is converted into mission code through compiler. Very wrong idea. Okay, some misunderstanding by seeing the word called mission. Okay, okay. Robotics. Okay, in robotics, this machine learning will be used. Mr. Reva. Okay, okay, very good, very good. Good answers. Yeah. Okay, let's clear that misunderstanding. What exactly the thing is? Deepak, you said predict the output. So what we are saying is in statistics also we are doing the predictions. In machine learning also we are doing the predictions. Okay, then what exactly the difference? A simple understanding. Machine learning is an approach simply to train models. Up to now, sir, we are training. I am giving training. You are taking. You are doing learning. So I am a human. You are a human. Human to human, the training is happening. But when you step into the machine learning, what happens is you are trainer, but your learner is not human. A model will be the learner. Okay. So here, what exactly the model? We need to understand this one. In machine learning, we don't train machine, we train model. After that, this model we will deploy into application or in any machine. So here one point is here model. We have a word called model here. What exactly the model is? Model is a mathematical predictive equation. Predictive equation. That means the math equation should give the prediction. Example, one simple example. I'm saying that y equal to mx plus c. Already this kind of equation you have seen in our basic mathematics. Okay. What is this equation? This is the equation of straight line. Okay. The equation of straight line. But every straight line is not a predictive equation. Every straight line is not a predictive equation. So here I write the same statement. Every straight line, I mean every equation is not a predictive equation. Okay, that means not a model. Observe this one, y equal to a plus bx some equation I am taking. This is a linear regression equation. This equation gives prediction. Okay, this is treated as model. In this way, many mathematical equations are there which can give you prediction. Okay, so such kind of predictive equations are called models. For example, I am giving one equation here, a simple, let's say income equal to 30 plus 5 into age plus 3 into experience. Try to consider this equation. Here age is your input variable, experience is input variable, income is target variable. This 35, 3, these are called weights here. Of course, in statistics, we call this first one as 30 as intercept here. And 5 is slope of age. And this 3 is slope of experience. So once I know your age and experience, if I have this equation, I can do prediction of your income. Okay. So based on the given data, we need to find out that relationship between input variables and output variables. Here, age, experience are input variables. Income is target variable. Okay, but how to in statistics, the way is once you know, so to find out the relationship between inputs and outputs, that means this intercept and slopes, we apply some formula, we fix some formula to find out that one. But in machine learning, the thing is not that one. The model itself will be learning the best weights, that means the best relationship between inputs and outputs. Got it. So come back to this equation. Let's go deeper into this one. So this is a linear regression equation. So what is the mathematics behind this linear regression? In the next session, we will be discussing. Think that this is one of the model. So generally, we write the same equation like this: y equal to w0 plus w1 into x. Here x is input variable and y is target variable. In machine learning, input variable is called feature, maybe single feature or multiple feature. This target variable is called label. So what are the thing I have written here W0? This is called intercept, statistically intercept. In machine learning, we call it as bias. And W1 is here is slope of input variable in slope of x. As per the given data, I know x, I know y. Suppose think that here x is your age and y is your income. In this way, I have data of some 100 people or 200 people. I know their inputs, I know their outputs, but I don't know the relationship between inputs and outputs. So we need to train that one. Same thing, same linear regression in a linear algebra style. That means linear regression equation in matrix style. Y equal to x dot w. Okay, y equal to x dot w. So x is here input matrix. Okay, y is target matrix, I mean label matrix. W is a weight matrix. This weight matrix contains this bias and slopes. Got it. So in statistics, what we do to find out this W, we apply some formula. Okay, but in machine learning, we train model. Model itself will be learning the best weights, the relationship between all these things. So how it works, we try to understand here. The training steps will be like this. First step, initiate random weights. That means initially it doesn't know what exactly the relationship between these things. So it will initiate some random weights, randomly take some weights. After that, the training loop. The training loop as a first work, it apply prediction. So with the help of this model, okay. So what exactly the model, later we will discuss. And second step, once prediction is applied, it measures error. Suppose actually, so what is exactly the meaning of error is, for example, first person, I'm talking about only age, sir. Think that first person age is 20, but prediction is saying that 2. Is it right prediction or wrong prediction? Think that this is you, your age is 20. But I'm predicting your age as, just by seeing your face, I'm predicting as 2. That is very wrong prediction, right? Okay. The difference between these two, that is called residual error. In this way, if I have 30 people data or 10 people data, suppose second person age is 30, my prediction is saying that 10, again wrong. 30 minus 10, which is 20. Okay. After that, 40 is the next person age. My prediction is saying that 20. 40 minus 20, again 20. So this is error 1 for the first record, error 2 for the second record, error 3 for the, so error 3 is the error for the third record. In this way, if I have 100 people, if you treat this one as a target variable, this y cap is a predicted variable, the residual errors are y minus y cap. Now, what is the overall error that is called mean square error? Mean square error means y minus y cap whole square. Just wait. Whole square. That means all errors, some errors are positive, some errors are negative. That's why like we are squaring this. For all these squares, we will apply average. This is called technically MSE, measure error. Here MSE will apply mean square error. Okay. Observe here, in the first iteration randomly I have taken, suppose given data is like this. Given data is age, experience and income. So first person is 20, experience 0, income is 25k. Next person is 30, experience 4, income is 70. Think that in this way you have 100 people data. Last person 40, experience 10, income 2 lakhs. So initially here, what are the input variables? So we cannot say just by seeing the data, we cannot say which is input, which is output. Based on the task, we need to understand. The task is based on age and experience, predict income. Now in the given data, I know inputs, outputs. I don't know relationship between them. Now I want to train my model to understand the relationships. So here what it is doing is initially random weights. Example, I am taking one matrix. This is the first 0.02. Let's say this is for the bias. The next one is 0.9. Think that this is the slope of age. After that 0.002, this is a slope of experience. Treat it as bias. And this one as slope of age, first input variable. And slope of income. This is second input variable. On that way, initially random weights it is taken. After that, it applies the prediction with the formula y equal to x dot w. Okay, forget about the mathematics, just what it is doing, just observe. But definitely with random weights, you applied that prediction, definitely there will be error. You have calculated that error. Think that you got 190 as error in the beginning. Okay, but this error because of these random weights, the error because of these random weights, to reduce that error, it applies one derivative. Derivative produces gradients. Okay, so why you are applying derivative is to reduce error. In order to reduce that error, you need to do some modification in the given weights. After that, in the fourth step, adjust the weights. Let's say W plus equal to my gradients into some learning rate. What is the need of learning rate? Later we will discuss. Now, previous weights are random, very bad weights now. After completion of this derivative, once gradients are produced, you are adjusting these weights to the previous weights. Now weights got modified and go to the next iteration. Suppose iteration number 1 completed. Now you entered into second iteration. Again with the latest weights, already weights got modified. With help of latest weights, you are applying the prediction. Again, you are calculating the error. Think that in this case, the error should be less than to the previous error. In my first iteration, I got 190. After that, weights got modified here. With the latest weights, again, if you apply the prediction, I got error 150. The next iteration error should be less than to previous iteration error. But still error exists. That's why, again, it is applying derivative. After that, it is adjusting the weights. Now you are going to the third iteration. In the third iteration, again, if you calculate this error, the error should be less than to the second iteration. In the second iteration, we got 150. Now this might be 100. In this way, think that iteration 1, I got 190. In the iteration 2, 150. Iteration 3, let's say 100. In this way, think that already 100 iterations got completed. Iteration 100. Let's say in this moment, the error is number 2. Iteration 101. Again, I got 2. Look into the last 2 rows, sir, all of you. Look into the last 2 iterations. Bias means some hidden force here. Just wait, like how, so try to understand how exactly the model is learning. Observe here, last iteration error, 101 error, 2. 100 iteration error, 2. That means current error and previous error became equal. Current error and previous error became equal. Then this is the indication when current error and previous iteration error are equal, training is completed. Now onwards, how many iterations you run? There will be no change in the error. Suppose iteration 1 or 2 again, if you run, already it achieved 2. Now also it will be a 2 only. That means whenever current error, previous error both become equal, the training part is completed. After completion of the training, whatever the weights you have in the last iteration, those are the best weights. Got it? So same thing pictorially if you want to understand. Let me take this. Think that in our case, age, experience are inputs. I mean input variables. Income is target variable. So first of all, some data preparation step will be there. We need to prepare input matrix. Think that I have 100 rows. The size of this matrix is 100 rows and 3 columns. 1 column extra I am keeping reserving for the bias. How to prepare this data later we will see in the technical part. And I need to prepare 1 label matrix. That means target matrix, that is income. I have 100 people, 1 column. Okay. So now the thing will be like this. Treat this cell as the first one is for bias, some hidden force. Second is input variable age. The last is input variable experience. My target variable here is, sir, can you please keep on typing the chart? Because try to concentrate, because if chat message is updated again, my concentration is diverted here. Observe here, I am keeping in the last cell income. Income is our target variable. But here bias, it has some hidden force on the target, and age has its own force on the target. At the same time, experience is also having some force on the target. These things we are saying it as first one as a bias, which is W0. Second one as W1, which is slope of age. Third one as slope of weight, like this. Okay, so this is what our random matrix, initially random weights it is creating. So this W size here, definitely there will be 3 rows, one for the W0, W1, W2, and 1 column, like this. Initially random weights it is taking. Come on, let's apply the training steps. First it is applying some prediction. Step 1 is prediction. The prediction y equal to, let's say, x dot w. What is the size of this matrix? Let's give the symbol called y cap. Y cap equal to x dot w. Always whenever you see y, that is as actual, and y cap is a prediction. So its size is like definitely 100 rows, 1 column, because I am taking 100 records. So once I applied the prediction, next step you need to calculate the error. Let's say MSC, for our easy understanding, I got 190 in the first iteration. After that, we need to apply derivative. So for the derivative, the symbol I am using delta. X transpose dot of, forget about mathematics formulas. Y minus y cap, whole divided by number of elements. This size should be same as this W. Sir, as per this one, whether it is correct or not, try to validate this a little. I hope all of you have completed basic matrix computations. X transpose means, transpose means rows has columns, columns has rows. What is the X size, sir? 100 rows, 3 columns. X transpose size will be what? 3 rows, 100 columns. Y minus y cap, 100 by 1. What is the matrix multiplication rule? Number of columns of left side, number of rows of right side should be equal. Here 100, 100 both are equal. That's why I got 3 rows, 1 column. Understood about this. Now this delta size should be same as this W. After that, you are adjusting that W. You are modifying that W. W plus equal to some delta. Now, previously wrong weights. Now the weights got modified. With the latest weights, again it applies the prediction. This time, definitely error should be less than to previous. Suppose previously I got 190. Now definitely it should be less than to that one. Maybe 150 or 130 or 120. It doesn't matter. In this way, maybe 100 iterations or 200 iterations, or sometimes it can be even thousands or lakhs of iterations also. Finally, one fine iteration, what happens is your current error, previous error, both will become equal. For example, in the last iteration, I got, let's say 5. In the next iteration also, I got 5 means the training is completed. So here the steps are like this. First, we are taking random weights. By taking the random weights, we apply the prediction. Once prediction is done, calculating the error. Once error is found out, to reduce that error, we are applying derivative. After that, the derivative output we are adjusting to the previous weights. With once weights got modified, again you are applying prediction. This is called a training loop. Understand? So here you are not teaching the relationship between input and outputs here. Model itself is learning. Model itself is learning. That means initially model is doing some prediction and calculating the error. To reduce the error, applying the derivative, later modifying the weights, adjusting the weights. So do the mistake and rectify the mistake. Do the mistake, rectify the mistake. On that style, the machine learning model itself is doing self-learning. Got it? So here I am coming back to this discussion. Now try to understand the ML style now. In the case of ML, the ML developer or AI developer, these are the trainers. Let's say you are that one. You are trainer. Your learner is model, not human. Got it. Now please try to answer what model learns. By seeing this picture, try to say answer. Finally, after trying the model, what model learns? That is my question. Model learns data, no. Steps and calculations, no. No, no. This answer is somewhat good. The behavior of the data. I mean patterns within the data. Yes, sir, Mr. Pranay and Satyapavan. Correctly you said. Finally, after completion of this one, finally what model learns is the relationship between features and labels. That means the relationships between input variables and output variables. Got it? Okay. So later, like in the practical part, we will see how the error will be reduced, how your finally your model is going to learn. Let's answer this one. What model length means? What is your answer? Weights. Model length weights. That means the relationships between inputs and outputs. Okay. Okay, sir. Here I am training you. For example, let's talk about human to human training. How one human is training other human? Number one, with help of information. Second one, with help of some tool. Of course, in our case, our tool is this laptop and this Zoom meeting. These are the tools. Information, what are the information that I have already, okay, that I am sharing with you. So in the case of human to human, like with information and some tools, we are training the people. But here, again, come back to this one. With what you are training the model? Two things again, please try to understand. Now your trainer, the model is your student, that means learner. But my question is, with what you are training the model? With what you are training the model, please. So they are almost correct. Kartika, very perfect. Data and algorithm. Data and algorithm. Mayur, you said based on the data. Okay, data okay, but what about the algorithm? Right? Okay, you're training with two things. One is with the data, second one is algorithm. Whatever the algorithm I just explained here, this algorithm is called gradient descent algorithm. What is the behavior of the gradient? What is the nature of the gradient descent algorithm? How it works? First, it is initiating random weights. After that, applying the prediction. After that, calculating the error. That means measuring error. To reduce the error, it is applying derivative. After that, it is modifying weights. That means if you treat this weight as a knowledge of the model, here initially bad knowledge, after completion of entire training, the model achieves a good knowledge. Got it? So again, I'm coming back to the notes. With what you train the model? That is my question. With what you train the model? What is the answer? With data and algorithm. These algorithms are called optimizers. Optimize means optimization of the error. Previously, some biggest loss. So technically, this error is called loss function. Previously, in the beginning, I got 190 error, next 150, next 100. In this way, every time it is trying to reduce the loss. That's why those kind of algorithms are called optimizers. So without data, we are not able to train the model. So you have data, but no algorithm, you cannot train the model. Got it? So if you do say that, if you treat this data as information and this algorithm is working as a brain, this is one of the general question, how a brainless model can get trained. Then what is our answer? With help of data and algorithm. Whatever the algorithm that we have used, that is called gradient descent algorithm. In this way, many other algorithms are there. Gradient descent algorithm. This gradient descent is acting as a brain to your model. The question is how a brainless models can get trained means with the help of optimizers. One of the popular optimizer is gradient descent. In this way, other optimizers also available. Got it? Okay. Now, data contains what, especially in this example. Again, two things. Come back to the picture, please. I have given 100 people data to you. In that data, I have age, experience, and income. After that, you divided the data into the two parts. You prepare two matrices. One is X, second one is Y. What is X here? X contains input variables. Y contains target variable, I mean label. All input variables here called as features. The target variables are called labels. That means here the thing is data contains what here, especially in this example, features and labels. Features and labels. Got it. Okay. Now observe here. After training the model, we need to test accuracy. That means out of 100, how many predictions are good? For example, out of 100, your model is giving 30 predictions perfectly. The 30 predictions are good, remaining 70% of the predictions are bad. Then what is your accuracy of your model? 30%. Got it. 30% means not satisfied. Suppose you have a benchmark of 90%. 90% prediction means 90% accuracy means out of 10, at least 9 predictions should be perfect. In some cases, I will expect a 99% of accuracy. Of course, 100% accuracy we cannot generally achieve it, but we try to reach it. We try to reach the 100, maybe 99.99 or 98, such kind of accuracy also we are expecting. It depends on the situation. Got it. So once model accuracy got satisfied, we deploy model and model fit. Simply for easy understanding, I am saying that model weights into application. Whatever the application, software application that you have, we will deploy that model into along with the weights, along with the trained knowledge. Not before training. After completion of training, the trained knowledge we will deploy into the application. Then your application become artificial intelligence application. Got it. Up to now clear, sir, all of you? Now tell me, now I am expecting answer from you guys. Now tell me, stat versus ML. Stat versus ML. Please try. As per the up to now, whatever the discussion we have done, depends on that. You tell me your conclusion. In statistics, we have the same equation, y equal to x dot w. In machine learning also, we have the same predictive equation, y equal to x dot w. But statistical style different, machine learning style different. And don't say that statistics is not good for the prediction. Some cases it may be good, better compared with machine learning also. Yes, Sai Deepak, you said perfectly. Stat does not include continuous learning. Only one time it applies the prediction, that's it, by fixing some formula. But in machine learning, you have seen, first it is taking random, before training, it doesn't know. That means it doesn't have any knowledge. Applies the prediction. Okay. And calculating the error. To reduce the error, it is applying derivative. Later, it is adjusting. In the first iteration, some biggest error, second iteration, error reduced, third iteration, again, error reduced. In this way, after few iterations, the training part will be completed. Finally, it learns what are all the possible patterns from the data the model itself is learning. I hope all of you clear up to now the difference between stat and this ML. Okay. Of course, there's a lot of models are derived from the statistics department only, but here the style is different. Got it? Vaishnavi, that is very correct. Machine learning has the ability to learn without being explicitly programmed. Only you have to program for this to implementation of this algorithm, that's it. But you need not to write any programming for to learn this W, to like, what do you mean, to find out the dimensions of this W. Got it? Only for the algorithm implementation only you are writing the code. Not to find out the W, you are not writing any code here. Okay? Model itself is doing the learning. Understood? Yeah. A simple demonstration for you, sir. So please, if you are new to the Python, okay, don't worry. Just try to understand whether error being reduced or not. You just trying to do that. Trying to observe that one. I'm opening my Colab, Google Colab. So don't be panicked by seeing that Python statements. If you are new to the Python, don't worry. Let's work with some data. Okay, here I have some data. The machine learning style observe, sir. Only data part I am taking here. Google Colab. I'm opening a fresh notebook. Just connecting with the Python runtime here. So without installing Python, you can practice entire stuff in the Google Colab. Only Gmail account is required for you. Okay, that is connected. Sir, here observe. I'm taking three variables: age, experience, and income. Okay. Think that the first array is for first list is for age, second is for experience, third is for income. Suppose look into the first person. First person age is 20, his experience is 0, his income is 43. Initially, I am going to take random weights. Forget about the statement, sir. Try to understand whether error is being reduced or not. I am fixing some seed value here every time to produce same values. Now W equal to NP dot random dot random. How many input variables? Two input variables. That means three rows. One for bias. One bias, two slopes. One column I am taking. Three rows, one column. Okay, let's keep it here as into 2 minus 1 because it is producing only the values between 0 to 1 only. To keep some values positive, some values negative, I multiplied with the 2 and subtracting with 1. Check the random weights now. Okay, first one is bias. Second one is slope of age. Third one is slope of weight. Initially random weights I have taken. Okay, I am doing some training. Before training, some trials I am doing. Let's say this is trial number 1. What are the training steps? Are seeing the picture and tell me, please. See the pic and tell me. First step is prediction. I'm going to apply now. All of you, please observe. Let's say y cap equal to x dot of w. Here dot indicates matrix multiplication. After that, I need MSC. Second step is error. Okay, MSC. Mean square error. Mean square error means y minus y cap. You don't worry, here I am writing mathematical statements. In machine learning libraries, we have predefined functions for all these things. Don't be panic about the mathematics background here. Y minus y cap. For all these errors, I am applying square. In Python, to apply the square, we use double asterisk symbol, double star, 2. For these squares, we are applying mean. Mean means average, simple average here. Second step is also completed. What is the third step? Look into the third step, sir. We need to apply derivative. Okay. So first I am printing the data, MSC. That means error. Or in machine learning, the actual terminology is loss. After that, I am going to find out this, apply this derivative. The derivative output I am keeping into delta. Y minus, sorry, X transpose multiplied with Y minus Y cap whole divided by number of elements. Let's say len of age or len of income. Now delta third step is also ready as part of your training. So first of all, we did not prepare input matrix, right? So before random weights, here I will prepare input matrix. Once equal to first column once I am keeping for the bias purpose. NP dot ones of len of age. I'm going to prepare input matrix NP dot C underscore. That means column binding here. First column I need ones. Why first column once we are keeping in mathematical part of explanation, I will explain. For now, just keep concentrate. Second variable is second column is age. Third column is experience. Spell mistake. Experience. Now I have totally 8 rows, sir. So that matrix size should be 8 rows, 3 columns. Let's check it. X dot shape. I have 8 rows here in the given data and I have 3 columns. Check output of this one. First column once I have kept. Second column is age. Third column is experience. Similarly, I am preparing output matrix y equal to np dot c underscore of what is our target variable here, which is income. I have 8 rows, 1 column here. Check that one. Print y. Now input matrix ready, output matrix ready. We need to find out the relationship. Now we are going to try, and before training, we initiated random weights. Now I am doing the trial number 1. After that, I am adjusting the weights. The fourth step is what? Finally, once derivative is applied, we need to adjust the weights. Delta into some learning rate, I am fixing 0.002. That is to control the speed of the learning. In algorithm explanation, I will explain what exactly the learning rate is. So step 1, observe the step 1, prediction. Step 2, measure error. Step 3, apply derivative. After that, adjusting the weights. Treat this as first iteration. Okay. All of you tell me, you have error, right? Very biggest error that we have. Let's do the second trial, sir. In the end of the trial 1, W got modified. With the latest W, I am going to do trial number 2, which is iteration number 2. Let's say trial 2. I'm keeping the same. Now, what is expected functionality? What is expected functionality, sir? In the first iteration, what is the error? In the second iteration, what is the error? The error decreased or increased? Please tell me your understanding. What is your observation here? Did you observe this, all of you? Error got decreased, right? That means now in the beginning you have some W, now we have some W. Which W is best? Which W is best, sir? Second W is best because error is less for that. Got it? Okay, one more trial, please. One more trial, please. One more trial. Let's say trial number 3. Trial number 3. This time, when compared with the second iteration, error should be more or less. Got it? That means whatever the theoretically we discussed, that is working fine. Got it? Okay, now let's completely train it. Let's completely train this. So what logic, what statements I am writing here in the Python, you don't worry. I'm fixing some convergence. something 0.0001, 10 to the power of -7, very less value. That means the difference between current error and previous error. If it is less than or equal to convergence, my training is completed. Okay. Okay. Let me go with a simple for loop for I in a range of, initially I am keeping 1 lakh iterations. Somewhat because I don't know how many iterations it is going to take. That's why some biggest count I have. What is the first step? Prediction. Second step, error. Let's say C error. C error means current error. Before current error, before loop, training loop, I am giving previous error. Initially, I am keeping 0. One flag I am setting here 0. Flag 0 means training not completed. Flag 1 means training is completed. C error, current error I mean. Y minus y cap square mean. Current error ready. For every 100 iterations, I want to print this error. Or for every 1000 iterations, I want to print this error. If I percentage equals to 0, that means it finds the remainder value. If it is 0, I'm printing the current error. Current error after, because I count starting from 0, that's why I plus 1 I am saying. I plus 1 iterations. Up to now 2 steps: prediction, calculation of error, then derivative. What is the formula we have taken for the derivative? X dot x transpose y minus y cap, all divided by len of age or anything, len of y, whatever it may be. Let's take len of y. Now derivative also ready. Then you are adjusting the weights, delta into some learning rate. If the difference between current error and previous error, if it is less than or equal to this much of small value, then my training is completed. If absolute difference of, I mean previous error minus current error, is less than or equals to the given convergence, then training is completed. I am printing some message to the user. Training is completed. After how many iterations it has taken to understand that, I am printing I plus 1 iterations. Once training is completed, I am setting flag value as 1. If flag value 1 means training is completed, no need to go to the next iteration. Then I am breaking this. Before going for the next iteration, I am directing current error into previous error. Now my loop is completed. The training loop is completed. Of course, here wantedly I am writing the code to understand what is happening at each step. But in fact, we have predefined functions here. Just in 1 or 2 lines of statement, you can finish the training part. But to internally, what is happening, to understand that, I am writing the length of the code here. Okay. Observe, after completion of the loop, suppose loop runs for 1000 iterations, 1 lakh iterations, I am sorry. Still flag value 0 means what? Training is not completed. Training is not completed. Run few more iterations. So this is just a message to the user to understand it. Okay. So now please observe this. I'm going to train the model now. Already 3 iterations completed, sir. Okay, let's come to the beginning. Again, I am reinitiating to the initial random weights. So these are the initial random weights. Okay, let's store into a separate W. This is a pre-trained W. and without copy of this stuff, because later in the climax I want to compare this one. Now I'm going to try. This is our training loop. All of you keep concentrate here. What is happening? Please check in the first iteration. Okay, many iterations it has taken. We did not print. Where is that printing statement? Current error. Here I am printing C error. That means current iteration error. Let me bring to the beginning state, which is random weights. Now random weights ready. Now I'm going to try this. Now you have to tell me your understanding here. By seeing the output, you tell me. Let's look into from the beginning. In very first iteration, sir, what was the error, sir? 7,410, very biggest error. After completion of next 1,000 iterations, what happened, sir? Your error is 0.023. Before training, 7,400 change. Now after 1,000 iterations only, it became 0.02. That means already very close to the zero. Got it? Come on, sir. Just for every line, please check whether error is decreasing or not. When compared with first line, in the second line, error decreased. Now compare again. Here 0.0237, here 0.0235. Decreased or not? Decreased. Again here decreased. In this way, for every iteration, error is keep on decreasing, decreasing, decreasing. Now finally check the final output. What happened here? Whether training completed or not, we need to understand. The training is completed after how many iterations? 88,347 iterations. Got it? Now check the before training, what was there in the W. After training, what is there in the W? Just check it. This is before training, pre-W. The values are like this, very bad weights. Now check this one, print W. This is after training. These are the best weights. Understood, all of you? If I do prediction based on this one, then my predictions will be good. Of course, before applying the prediction on the live data, you need to test the accuracy. That means you need to evaluate the model. So that life cycle process, everything step by step, we will be discussing. So don't worry about Python code and everything. If you are new to the Python basics we will discuss, and then the mathematical part we will discuss. Then finally we will implement the model. End of the day, like I will make sure you could able to train our own models. Okay, that much confident I can give you. I hope all of you understand the style of this one. The style, machine learning model, statistical style. What is the difference? Here, model itself is learning these best weights. Model itself is learning these best weights. So again, come back to this one. Please answer these questions again. Once again, recall these questions. Already prepared here for you. Who is trainer means you are the trainer. That means ML developer is the trainer or data scientist is the trainer. And learner means not human, that is a model. What model learns? Weights. Already have seen just now the demonstration. Model finally learns after training the weights. The weights are constructing relationships between inputs and outputs. So with what we train the model means we are taking two weapons here. One is data, second one is algorithm. That means optimizer. Why we call it as optimizer means it is trying to reduce the error every iteration. It is optimizing your loss. Got it? Satya, don't worry. Just today, I would like to demonstrate only this one. what exactly to understand what exactly the machine learning is. Machine learning is finally achieving what? Iteration to iteration, less error. Finally, it is learning the things. Okay, best relationships between inputs and outputs. It is learning. Tomorrow, the next class onwards, we will be entering into the basics. There we will go in that style. This is just a demonstration. Okay. Okay, come on. Basic onwards, I will teach you, sir. All of you. Don't worry about it. Hmm. Come to this one. Finally, what? Here is our question previously. With what you train the model means we need two things. One is data. Second one is algorithm. That means optimizer. And data contains what? Especially in this example. Of course, we in machine learning we have different disciplines, sir, like supervised learning, unsupervised learning, semi-supervised learning, self-supervised learning. In this way, different other types. These are types of machine learning. Especially whatever the work we have done that is called supervised. But what exactly the supervised we will discuss in the next class. Okay. And data contains finally features and labels. Here in supervised learning, features means input variables, labels means target variables. Got it? So once model is got trained perfectly, we need to test accuracy. That means evaluation of the model. Think that that accuracy you are satisfied with that. Once accuracy got satisfied, you need to deploy the model and weights into the application. Of course, this is completely ML engineer responsibility. He will use special concept called ML ops, machine learning and operations. Okay. So whenever you deploy your trained model and model knowledge into the application, then your model will become AI application. Understand? That is what exactly AI. In fact, AI means AI is a different set of sub-disciplines like machine learning, NLP, deep learning, like that. So today we understood about like in what way machine learning works. Then in the tomorrow's session, where I target is what is the limitation of machine learning? Why the next discipline called it deep learning? In fact, deep learning is a subset of machine learning only, but basic machine learning models cannot do something. What it cannot do, how deep learning will solve that problem. Okay. So why we should use both machine learning and deep learning in our AI applications? That concept clearly we try to understand. Okay. So the prerequisite, especially to learn this, is the Python program. That's why in the training part, like first we start with the Python and then the NumPy, and little knowledge about pandas will help you. Okay. So once you know the Python, as we are working with our models, you will be learning automatically the NumPy and pandas. Don't worry. And some other prerequisite is a little about SQL, not master level. Some basic knowledge of SQL will help you. Okay, and Python programming concepts. And if it is machine learning, definitely that is so that is a new for you. We will start discussing about machine learning fundamentals to up to master level. Okay. So timings already announced. That is so Monday onwards. Like so, tomorrow also we'll be discussing little, but Monday onwards we will be entering into the technicals, pure technicals. So then timing will be 7 to 8:30. Okay. So that too like one day training, and second day will be the mentorship will provide. Okay. So mentorship team will be involving with you guys from Monday onwards. So Monday session, if I take it, so Tuesday will be the mentorship program. They will make you to do the practice. Okay. So in this way, like the trainings, but some cases like Saturday and Sunday, at least we will try to spend. So let's forget about Sunday. At least in Saturday, we try to spend some 2 to 3 hours. Okay. So this week in the beginning, like slowly we will go from tomorrow onwards, and Monday onwards like a little increase the duration. Okay. So prerequisite already I told you, Python and SQL. Of course, we start the things from the Python only. Don't worry, if you are new to the Python also you can catch. Already you have Python idea, no problem. Here different techniques you will be learning, especially in data science and machine learning style. Okay, even though you know Python, attend the Python sessions also in the beginning. Okay, yeah. So any questions, sir? Like anything you want to ask me? Yes, sir, Mayur. Notes will be provided, recorded sessions will be provided, everything will be provided. Today, what we have done is basic demonstration. That's it. How machine learning is going to reduce the loss, how it learns. That is the thing. Daily class notes will be sharing you, and also the recorded session. Yes, Satya. Yes, yes. Automatically attendance is registered. Attendance is registered. Okay, because in the Zoom meeting after registration of the thing only you are able to enter into the session. Okay, all. Thank you very much. Thanks for spending. So tomorrow also we will connect at 7. But tomorrow very little we discuss, and Monday onwards we go for the 1.5 hour. Thank you, sir. Thank you very much. Bye bye. Jitendra, anything you want to ask? Oh, sir, class certificate means definitely we give you that certification as a training completion certificate. We can give you, but not as an expert certification. Expert certification means that we cannot certify you that you became expert into this one. That is within you only. Okay. But I recommend you some international certificates, so please do that one, like Azure, Microsoft certifications, Google certifications. In this way, different certifications are available. So I recommend you those things. Which certification is more demanded, I will tell you. Okay. Yes, Deepak. In AI part, we will be learning machine learning, deep learning. Okay. Of course, while working with deep learning, some play with NLP will also will be happening. And if it is project, the scenarios will be the project. After completion of the training, I will assign you the projects. Okay. Because as part of this training, we cannot touch the project. Again, the topics will be diverted. After completion of the training, I give you the projects. Okay. So here, why we initially take random weights means treat that random weight is a bad knowledge, because we don't know what exactly the weight, the relationship between the input and weight. That's why we initially random we have taken. Definitely that is a bad weight. After that, after training, that has land best weight. Yes, sir. Its duration will be 1 month. Yeah, we try to. That's why, like in some weekends, at least Saturday, Sunday, we try to spend 2 to 3 hours. Okay. Yeah, I help you in preparation of your CV. No problem. So for now, not PDF. This entire plain text will be shared with you guys. Max by afternoon. Okay, or by today evening, you will get all the recorded and this notes also. Don't worry. Okay, shall we meet tomorrow? Let's stop this. Sir, this certificate is just to showcase. That's it. Whatever the certificate that we have given to you, that is just to showcase, but it won't like any international value for you. But the thing, if you go with Microsoft certification, okay, or else AWS, Amazon certification, so these kind of certifications will help you. Okay. So after in the climax of our training part, like I will guide you which certification that you need to do. Okay. I promise you, don't worry about your previous background. Okay. If you are passionate to learn this, definitely I will help you. Okay. No problem. It doesn't matter whether mechanical or electrical. It doesn't matter. Okay, sir. I'm leaving. Thank you. Thank you very much. Tomorrow same time we will meet, sir.